So good morning, one and all, and again we are continuing with lab session with part two, how the process of system software and operating system labs is going to be implemented. And now we look on with the introduction. What are the packages and softwares that are required to compile and execute your system software and operating system programs, right? And before start with any programming languages or any type of practical session, so most important concept is prerequisite. What are the prerequisite is required means before going for any specific laboratory process, user has to identify what is the pre-knowledge should be there. So what exactly that user has to know, basic preliminary concepts, prerequisite concepts. So that stands the prerequisites for your system software lab, right? So basically if you want to start with the system software lab, what's a basic prerequisite and preliminary that is needed for all the students and all the faculties is, so the personal computer or a systems is going to be installed with an Ubuntu or Linux based operating system. That's a mandatory. In case if you're using with an Windows operating systems, you have an option of installing with an VMware software, or else you can use with the Cygwin interface in order to install with an Unix based family operating system, right? So that's the first criteria that has to be known. And again, user has to know the basic commands like how to create a file, how to save the file with the different editors like a VA editor, gedit, gnome, and how the commands are going to be interacted, and different types of shells that are available in Unix operating system, bash shell, C shell, and different type of commands like shell oriented commands, file oriented command, directory oriented command. All different types of commands as a basic knowledge should be there for your laboratory programs, right? And nextly, what are the softwares that are required? So if you want to run your Lex program, what software is needed and how to install that software, that is very important, right? As a student, we will be directly going for a lab and we will start writing with and implementing the program. But before that, user has to verify how to install with the packages, how to install with the softwares, and how we can start up with the laboratory part, right? So if you want to start your Lex program, very simplified command that is to be added for your terminal or in your system is sudo apt-get install flex. Once if you install with this statement, automatically the Lex packages and the softwares are going to be installed in your computers, and then you can run your Lex programs, right? And same thing if you want to implement your YAC programs, if you want to run your hack program, so the simple command to install the package or a software is sudo sud superuser2 apt-get installed bison. So then after performing the two different steps of installing both the lexical and YAC programs, then user can update the system. Sometimes there may be chances the system is already updated, so directly it will install. Sometimes it is not updated, it is a user responsibility to update the operating system. And you can also upgrade your operating system if you require with any recent updates for a particular specific questions of your operating system. So this is the basic criteria that should be needed before start to execute your any system software and operating system lab, right? And what exactly translator? Why we require translator? So as we discussed in theory class, translator is going to be converting one form of program into another form. The language written in an high level language is converted into machine understandable language. So this is a theory part, and what exactly the translation process, how the translation process are going to be converting, what are the different types of compilers are needed, all the basics you are going to be learning it in a translator process, right? And just it is in compiler design phases, how it is going to be implemented. So source code will be given, then lexical analyzer it will generate say tokens or identifiers, then syntax analyzer will take a tokens or identifier as an input, then again it is going to be takes an syntax tree. So as you can see, patterns are important for lexical phase, grammar is important for YAC phase, right? Lexical phase is also called it as a scanner, YAC phase is also called it as an parser, and afterwards it will generate an intermediate code. So this is a basic compilation sequence, how that each compiler is going to be undergone when you're compiling the program, when you're converting high level language into machine understandable language, right? And Lex, it is a theory part, introduction to Lex. Again, we have discussed in compiler design, the first phase of a compiler. So what is Lex and how that Lex is going to be implemented, what's the different syntaxes that user has to be follow, and the three different syntaxes also we have studied in theory part. So declaration section, rule section, followed by main sections, and by using the three sections, user is going to be implementing the program as you can see it here in the Lex program structure, right? So and again, when you're writing any program, each and every program is having their own extension. Each and every program is having their own extension. That extension will going to be specify what type of program you're going to be saving in your systems, right? Same as C program .c and C++ .cpp and Java as .java, HTML as .html. Lex program is always going to be extended with an .l extension where you are going to be saving your Lex program as a structural part, right? So as you can see, x.l means it is a Lex file, and as you can see it here, so this will specifies your completely declaration section, what exactly that variables required and assigning the statement, everything, and followed by your rule section. The second section is your rule section, what pattern to be matched and what action to be carried out. That is going to be placed an important rule in the Lex program. And then finally main method, or we can call it as an any user code in the form of an auxiliary subroutines that is going to be handled, right? And this gives you a simplified Lex program structure for system software and operating system lab, right? And again, YAC process, Lex for pattern patching, how the pattern matches will be done, will be there. And next we're going for simplified representations. So when you want to process your Lex program will be given to Lex compiler. The Lex compiler will generate lex.yy.c. A C file will be generated. That C file will be given as an input to C compiler. Then it will generate an output file. For that output file, user has to pass an input. Then it will generate a tokens. This token will be passed as an input to your YAC program. So this gives you a diagrammatical representation how the sequence of execution is going to be implemented for your Lex programs, right? And these are all the Lex variables that are available in your Lex programs. So YY_in, it is just a type of file. YY_out, it's a type of output file. YY_text, it is going to be matching the pattern, and YY_len, it is going to match length of the pattern, and YY_len_in, it will provide current line number of a particular information, right? So few variables we are going to be added. So similarly, different types of variables are required, n number of variables are available. And again, we just move for Lex functions. So YY_lex, it's going to be automatically generated by Lex. YY_wrap, that specifies an end of file, or when input is going to be ended, that terminates accepting an input from a user. Then YY_less, this function is used to push back all the first characters of 3 tokens from the compilation part. Then YY_more, it's going to be tells the lexer to append next token to the current token. That is going to be carried out to implement lexical phase and syntax phase. That's some Lex functions. And some regular expressions. So dot specifies any character except new line, and dot before that slash literal, and a slash and represents a new line, slash t represents a type, like that. Some regular expressions we are going to be representing. It is just a pattern, what patterns to be given, and based on the pattern how that characters or a sequence of characters are going to be processed. That is a regular expression. And again, here some examples. What that question mark represents, it's nothing but 0 or 1 copy of preceding examples, and star represents 0 or 1 copies of preceding example, and plus represents 1 or more, like the different combinations of examples are represented. So just to identify what exactly regular expression and patterns are going to be represented for your given application of your system software. And again, some more examples. So that example is in the form of an pattern matching in terms of meta characters. If I represent it within square brace ABC, it will take either any one, either A, B, or as well as C, and A to Z, it will take any letter between A to Z, but only it will take any letter only once. So it depends on the applications. User is going to be writing the different types of characters, patterns, recognitions, everything is going to be added, right? And directly we go for YAC. So Lex is the first phase, and YAC specifies your second phase. That's a syntax analysis part, and we can also call it as a parser phase. And the full form of YAC represents yet another compiler. The full form for Lex specifies lexical analyzer, right? So what is YAC? So as the name suggests, it is an second phase of the compiler. So it is always going to be takes token as an input, then it generates an represents an parse t as an output. So tokens generated is going to be taken by an YAC, and it is going to be verified the syntax. Then it is going to be generated as a syntax t, or it is also called it as an parse t. So what is the programming structure for YAC? So same as lexical programming structure, YAC is also consists of 3 different sections. Firstly, definition section, where it will contain the global declaration, prototype, assignment, and all. Then production rule section. So what production and what rule you are going to be taking. So there also pattern action. Here production rule sections will be there. That is a grammar representation. As you studied in automata theory, that context free grammar. So grammar's rules you will be writing in terms of terminals and non-terminals, productions and symbols. And lastly, you will be having auxiliary subroutines, or we can call it as an main method. So this is a basic programming structure for your Yak program. Any Yak program, this is a common programming structure, mandatory, that has to be followed before implementing of your any Yak program. And very importantly, any Yak program, lexical program is mandatory. Without lexical program, Yak doesn't going to be taken any tokens, right? And next we move on to some basic examples. And again, compilation part, again yak -d followed by file name and gcc space y.tab.c -ly. You're linking the yak file, then to run the program /a dot out, right? And again, this diagram specifies how that yak process will be implemented, same as your lex. Once if you give an yak program to yak compiler, it will generate y.tab.c as an output. That y.tab.c will be given as an input to c compiler, that will generate a dot out. And for that a dot out, you will be giving some input, then it will generate an output for the given program. So this gives you diagrammatic representations how the flow of execution is implemented for an yak compiler, right? And this will gives the combination how that lex and yak together it can be compiled. So yak is going to be compiled and it will generate y.tab.c. It will be processed as a yy pass, and lex is going to be generating lex.yy.c, and again it is going to be processed by yylex, or it will be called by yylex. Then you are passing for the gcc, so that is a C compiler, and the gcc it will generate an output based on the input given by user. Then compiled output is going to be generated. This give a combination how that both will be compiled. And same thing as a lex program extension is .l, yak program extension is always going to be .y. .y specifies you're writing an yak program, right? And next we move on the compilation diagrammatical representations, how that compilations can be implemented as a scanner part as well as a parser part, how exactly that difference flow executions is implemented for a specific program. And symbol table is common for the both the phases, and it will be used as a specific symbol tables based on the symbols that is declared by user. Then it is going to be executes your program. And as I told, lexical is also called as a scanner, yak is also called it as a parser, right? And again, it's an operating systems concept. You'll be learning in detail in your operating system how that different states comes into picture in operating system, and how it's going to be avoided with the deadlock, multiple programming, multitasking, different scheduling algorithm, how the utilizations can be done, FCFS, SJF, SRTF, priority, round robin, multi-level queue scheduling, multi-level feedbacking, deadlock concept, and all deadlock prevention, bankers algorithm. Everything in detail you will be learning in your operating system concept. Just be looking with some basic programs, some basic introductions of your lex compilation structure program and yak compilation structures program, right? So just we go for an example program. First program, what is a program question is that user has to write a program to count the number of vowels and consonants in a given string, right? So it's a very simplified question. User has to write a simple lex program, and there you need to find total number of vowels and consonants. That's a user responsibility. So what's the main objective of this question is, user has to write a program as a lex program, as a lex programming structure, and user has to print the number of tokens in terms of vowels and consonants for a given string. So you need to count the total number of vowels and consonants in a given string, right? As I told, lexical program structure, firstly it is having a declaration section. So by seeing the question, we can easily identify we require minimum two variables. One is a vowel count, another is a consonant count. You can declare with an user defined data and initialize to 0, right? And nextly, what's the rule section? As I told, rule section is depends on the pattern and action. Pattern and action. So if I found particular pattern, then corresponding action is going to be taken care, right? So for a simplified vowels and consonant, as we know, if any characters that is in represented A, E, I, O, U that represents the vowels, other than that character represents a consonant, right? And both uppercase and lowercase will be considered as vowels, and again both uppercase and lowercase other than vowels will be considered as consonants. It's a simplified rule section. Pattern action is going to be carried out. Then you're going to be delimiting with two semi stars. So two stars in the form of two semicolons or representation in terms of a 2% sign, where that will represents your delimiter. So in the declaration section, you will be starting with the percentage symbol, then open brace, then again you will be terminating with the percentage symbol with closing brace. And delimiter for rule section, it is nothing but 2% symbol, and again it is terminated 2% symbol. And the main method, it is going to be starting with your int ywrap return one, and main method will be starting with the execution flow. Directly will be entering a string, and again you'll be calling yylex. It automatically calls the C compilations. It generates a token, then C compiler will going to be processed, and then it will generate some output. This is a very simplified simplified program to execute a lexical programming structure to count number of vowels and consonants in a given string, right? And nextly, another program, user has to write a program to count number of characters, words and space end of lines in a given input file, right? So in this question we are not writing the syntax completely with the help of the lex as well as yak syntax. We are just writing the lex program, but user has to take an input not from an user input. User has to take it from file input. Very important. Means firstly user has to create one file. As we know, file creation can be done in Unix by using a command fopen and followed by the argument, that is the name of the file and which mode you are going to be opening the file, whether for read purpose, write purpose as well as execute purpose. Based on that, file has to be created, and within the file what we created as an user defined file, which is of format of anything, that will be given to YYIN, that is an input file. And in that file user has to count the characters, how many characters are there, how many words are there, how many spaces are there, how many operators are there. You can give any type of rule section, you can give any type of rule section. That rule section has to be defined in such a way that it should satisfy objective of the program, right? And as I told in the declaration section, so C counting is required. So number of characters C, and number of word, space and number of lines, right? And followed by how we can calculate word, how we can identify that it is a word. As we know, word is nothing but sequence of statement or sequence of a string. So if I call computer science, computer is one word, science is another word. How we can differentiate it is a two words, because space exists between a two words, space exists between a two sequence of characters, hence I can call it as word. So hence we'll be representing it as tab. And again, if in next line if another type of characters or sequence of strings are available, then again we'll be taking as an slash, then followed by end of line, and any blank space will be there, it will be considered as an empty, right? And based on the declarations we'll be taking that word count, and that is a yy length as a function, inbuilt function, it will count the word. And the blank spaces will be there, s plus plus will be increased, end of line will be there, l plus plus will be increased, and any dots will be there, it's nothing but characters. Anything will be considered as a character. Even operators will be considered as a character, numbers will be considered as a characters. And whatever app will be called just to ensure there is no input to further process. Next, within a main method we are taking arguments in not equal to 0, then you will be printing the file is exist, then you will be creating a file argument v1 which is in a read mode, then you are calling y_lex, then you will be printing number of character, number of words, number of space and number of lines. So this is a very basic program, how exactly that lexical program structures can be created and how we can implement, right? And next we move on to another simplified example. So user has to write a program to count number of positive and negative numbers, positive and negative fractions. Very simple. How we can identify positive number? Any number which is having no sign, then it is a positive number. Any number which is having a sign with a minus, then it is called it as a negative numbers. Means positive number sometimes will be representing with sign, without sign, but negative number is nothing but always representing with an negative sign, that is nothing but minus. Same thing for a positive and negative fraction. Same thing we will be declaring the 4 variable in declaration section. Then we need to specify the rule section. Very importantly, what is the rule? So negative integer we can call it as a negative, then positive integer we can call it as a positive integer. Then fraction, it should be divisible. Any number which is divisible by 0.00 something plus 0.5 minus 0.7, like that, some number representations you will be giving as a rule section. Afterwards you are calling y_var app, then return main, then within a main function again you will be creating a file, and within that file we will be passing the numbers, you will be identifying that number, then you will be printing how many positive numbers, how many negative numbers, how many fraction numbers, how many positive, negative and positive fraction and negative fraction, everything you are going to be printing it in a printf statement, right? That is again another simplified lexical programming structure for your systems of an operating system, right? And next, fourth example, user has to write a program to count the number of scanf and printf in a C program. Means user is writing one C file as input, and within that they are writing the printf and scanf, but user has to count how many number of times that printf and scanf, and that should be replaced. For example, 2 times scanf and printf is available, that should be replaced with the corresponding readf and writef statements. So very important. So separate file has to be created which is a .c extension. Then again you need to count now scanf and printf, then you need to replace with the readf as well as writef. So hence we are taking pc and sc, so to identify the scanf as well as a printf. Then again we will be taking a printf statement. If printf will be there, it will be increment, and scanf will be there, it will be increment. Then that is a counting purpose we are adding it. But what is that rule we have taken? Printf is there if printf, scanf is there if printf, so that value is going to be replaced, but within that we will be printing it. Just argument 1 read, argument write. So whenever you are replacing with output file, so output file is going to be taking the data and copied automatically in your output file, right? So this is a very simplified example for identifying scanf and printf and replacing with an readf and writef. And next, fifth example program to recognize whether the same statement or a sentence is simple or compound. Any statement and but not will be there, then it is a compound statement. So computer science, it is not a compound statement. Computer science and engineering is a compound statement, because and is there. Any statement that are lengthy, any statement that are complex, any statement that contain with an and or but not, that statements will be considered as a complex statement. Like that, you will be declaring some rule sections, and within that rule sections will be incrementing it. Then within the main method, you will be using some simple equal to where, then the given statement is simple. If this value is not equal to 1, then given statement is compound, right? So these are the basic examples and the structure of both lex and act along with the programming syntax. And these basic examples you will practice with your any operating system, with any type of version of your lex and act. You practice it, and if you have any doubts, you just revert back in the YouTube channel. And thank you for watching the few examples on lex and act and all the introduction of lex and act programming structure. Next class we'll go for actual life cycle of your syllabus, and we'll come across with the different types of syntax